Hello and welcome to this 11th Dyalog Webinar, this week on creating and managing your own user commands. I apologize that the chat functionality may not be working, but at the end of the presentation I will be displaying contact information so that you'll be able to come with feedback and input and ask questions. So, if you're using APL, I'm sure you have used system commands. They do useful things like listing what you have in the workspace and opening editors, opening workspaces. But sometimes you want to have functionality at hand that isn't in the system commands. And of course you can't change the system commands because they're built into the system, hence the name. So let's say you wanted to have a system command that would say take a hex code and give you a character from that. It's good to have at hand. It's not something you want a function for that's just hanging out in your workspace. You might also want some options for it to go the other way. Or say when box display isn't enough to tell you about an array, you might want to have a little utility that gives you an expression back for an APL array like this. So the thing about system commands is that they begin with a closing parenthesis, and that indicates very clearly that it doesn't follow APL syntax. Indeed, you can call a system command just by itself, or you could give it an argument, and then some might even take modifiers, which are similar to the switches or options that you often have in command line interfaces. Enter user commands. So user commands are just like system commands, and they have exactly the same rules to their syntax, being not like normal APL syntax. So they are case insensitive, they can be called with or without arguments, with modifiers. The difference is that they have used a square closing bracket instead of a round closing parenthesis to indicate that they are user commands instead of system commands. So let's go have a look at some of the user commands that ship with Dyalog APL in a default install. So entering square bracket question mark will cause the system to list all the user commands that are currently active. The left-hand column is a group name, and these user commands are then organized into groups. The groups are not like APL namespaces in that you don't have to call a user command using its group name, but if there are duplicate names across groups, then you will have to specify it. And we can say this group called calculation utilities, and we can get a short description, a one-liner description of all the user commands that are in this group by using bracket question mark and the name of the group, and we get a listing with a short description for each one. Here are some user commands you may find a use for. There's one called version. You just call it by itself without any arguments, and it will list versions of various system parts. It's good if you have an issue and need to report it to see what you're dealing with. Here's a user command that takes an argument. It's a very useful one, especially one that you don't want to copy in any utility to do the same, because it will clutter your workspace or your namespace. What it does is it generates a map of a namespace. So it says here, this namespace has these variables and these are lists of functions, and it has a reference also, it tells you where the references goes. And something that user commands have that system commands don't have is the ability for the user commands to provide help about themselves. So this map user command, we can ask it for help, and it tells us a short introduction about it, and we can get additional help with additional question marks depending on which command it is, and it will tell us a whole lot more information about itself. So one user command you might have bumped into is display. Display will temporarily use a very verbose format for drawing arrays, so that you can clearly see the structure and the data type of every part of the array. Another user command that I tend to use a lot is when I need to look for something, and I can specify where I want to look for it. And as opposed to just plain searching for text, it allows me to specify I should be looking case insensitively or using regexes and patterns. And so it will find and indicate this for me. One of the most powerful user commands is called peek. It allows you to peek into a different workspace than where you are now, and execute a line of APL in there, in that other workspace, and come back out and give you the result. So again, the benefit of user commands is that they do not pollute. You're not copying in everything from that other workspace into this workspace in order to use what's in that workspace. Rather, it's just a temporary thing. There will be no effects afterwards. So here, let's peek into the defense workspace and get a calendar from 2 months ago. Here we go. One last benefit of user commands is that the code for them is stored in text files, and that makes it very easy for you to pick one up and send to your friend and have them also have this user command for their benefit. So here in summary, part of the syntax, there's a bit more, but this is the main gist of it, of how to call user commands. Question marks get you help and information about the commands, and you can either call the user commands by themselves or using the group name. So what makes up a user command? A user command, as I said, is in a text file. The text file needs to contain a namespace. It can really be a class also, if you're into that style of programming. But in any case, it has to be a space. And it's important that this namespace sets up its context, usually quad.io and quad.ml. And that's because we can't know where the user command will be loaded into and called from. And if you do not specify these system variables, then the namespace will inherit the values of whatever place they're being loaded into, and that might not fit with your code. So you should always specify the things that your code depends on. Then there are 3 functions that a user command namespace must have. The first one is the list function. That one takes care to tell the user command processor, the system, what command or which commands are being declared in this namespace. There's a run function, which is where your code will go to actually do the things you want done. And then there's a help function, which is what gets called when the user uses bracket question mark or multiple question marks to ask for help. Okay, now let's make one. So there's, of all things, a user command called unew that allows you to create a user command. It pops up a GUI, and you could populate this GUI, but we're just going to click through and say we're done. And it opens this editor, and it has already generated the basic structure with all these functions, everything we need to get started. I'll auto format that and close it as is. Just want to point out, notice that the name of the user command is in here, the name of the group, there is a one-liner description, and the functionality of the user command at this point, before we have populated, is just going to be outputting this line, and then the help is always going to be this text right here. So we'll close that, and we get asked if you want to save it. Sure, want to save it, and let's call that text.dialog. Okay, so it has been saved to this location. As you can see, we get a message back also that 87 commands reloaded, so that means this unew user command took care of saving it and adding this location that we saved it in to the list of locations that we load user commands from, and then it goes through, scans, and looks at which commands have been added and adds them. And that means right away we can list the user commands, and we can see we now have this group, my commands, and it has this character command inside. And we can ask for help on this group. And we can see this is the one-line description that was in the template that was generated for us. And we can ask for help on this command. We get this help text from the template. And finally, we can try running it. And that's the result that we get. So here we go. We have a user command made. Now we just need to populate it. So at all times, there's a utility user command called ULoad. You give it the name of a user command, and it will find the right location for of the source code for this user command, and it will take that namespace and load it into your current namespace in the workspace. Here we go, and that means we can go and edit this. And here's the template as we saw from before. So now let's try to make this user command actually do something useful. Firstly, we will add a proper description. And then we have the actual code to run the command. So because we're doing base conversions, I will set quad.io to 0. That makes it easier. And we're dealing with hexadecimal, so we will take the first 16 of the digits and the characters. And then we can filter the input with the digits. And that's because some people write hex codes with various decorations, like 0x in front or \u, and things afterwards too. So by taking the intersection with the proper hex digits, we just get the ones that we're interested in. And now we can convert this to hex simply by doing the 16 base of the lookup of the input into the digits. And finally, we return the new Unicode character that corresponds to this decimal code. And localize our variables for good order. Here we go. And then for the help, we'll say what I usually do is that I give it some basic help first, just to tell the user what the syntax is for calling this command. So the name of the command, and then we give it a hex code. That's how we want it to be called. This notation here has no impact on the functionality of the command. It's just an informal syntax that people tend to use to try to indicate how to call various command line programs. And then we can see the left argument to help is a level. So depending on how many question marks the user specifies when he asks for help, you can get different levels of help. First level is level 0, and I would say we always return the basic syntax of the command. And if the level is higher than 0, then we'll give the user a little bit more information. And it's a good idea also to give an example of the usage. So here would be and show them what they can type. Just for example. Okay, Now I can close this, and right away we can try the help. And you can see that the help text from this user command has now been updated. We can get the more advanced help. And now we can try this example that we were given. And we get the result back, this character. Now, I said that the unew user command amended the search path for user command code, but it only does so temporarily. If everything works like it did now, then we will want to keep this permanent so that next time we start APL, this user command is available. So we do this by saying that the settings of the command directories should be permanent. And you can see these are the search paths that it's looking in. It's responding with what the value was. But there's a little bit more we can do with user commands. This was very basic. So let's say we load a workspace, like defense. There's a fancy user command called functions like. You probably know about the system command parent fns, which just finds functions. It doesn't have any options other than listing by letter from a certain letter. Functions like can do a whole lot more. Just to show a little bit, it can take a regex, a regular expression. So here we want something where the name of function begins with a C, and then it has some word characters, specifically 2 or 3 word characters, and that's all for the name, and it's the end of the name. So I can specify that this is a regex, otherwise it would use glubbing like you use in the operating system command line. And we can specify that instead of displaying the result in columns across, just like the parent fns does, we just want a raw format going down, just a list. So we say do not format. And here we go, 3 and 4 letter names of functions that begin with a C. Right. So in order to do such a thing like we did, we would have to parse the input that the user gives. There was this regex, and there was this modifier saying that it was a regex, and there was a modifier that had a value, no. And while you could parse that yourself, the input is just a character vector, and you can just analyze that and figure out what it says. We do supply a parser that can help you with this. It makes it quite elegant. So we had the list function, and at the very bottom it had this parse variable as a member of the namespace that represents the user command. And as you can see here, it's just quote quote, just an empty text vector. That means that the run user command will get fed whatever text as a character vector that the user command was called with as an argument, as is, nothing modified at all. But there's a whole lot that can be done for you. I'm not going to go through everything. I'll take just the basics. It is fully documented, both online and in the help directory of your install folder of APL. So quote quote just means raw input. Whatever the user writes, quotes, double quotes, everything just gets fed in as one character vector, as is, and you have to take care of the parsing. If you give it a number inside this character vector, then it specifies the number of arguments. So this says my user command takes exactly 3 arguments. That means you don't have to worry about checking whether the user's command was called, whether the user command was called correctly. Rather, if the user tries to call your command using more or less arguments or no arguments at all, then the user command system will protest and tell the user that it needs to take exactly this many arguments. One less thing for you to worry about. You can also specify that you want 2 arguments, but the last one can have spaces in it. So we say the last one is long, it merges all the apparent arguments into a single argument at the end. So this was useful, for example, in the peek user command, where the first argument was the name of the workspace we wanted to peek into, and the rest is just a bunch of APL that needs to be executed. And we take all that and we bunch it together as a single argument. So the L here is for long, the last argument is long. And we can also specify a range between 2 and 3 arguments, so you can call it in only these 2 ways, and any other attempt at calling the user command processor will protest and say you can't call it like that. It needs to take 2 to 3 arguments. That's it for the arguments for now. Again, there are a lot more details which you can look up. We can also take these modifiers. So if in the parsing string you specify a modifier like this, then the user command processor will allow the user to supply this modifier, and no other modifiers will be allowed. It also allows the user to shorten down the modifier. So for example, instead of -mod in this case, they could just write -m, as long as it doesn't become ambiguous with any other modifiers that have been specified. And the user command processor again will make sure that what the user enters is not ambiguous. You can also specify, just like we had with this functions like user command, that a modifier should take a value, and then you do that with an equal sign after the name of the modifier. And you can specify that it may take a value, meaning either the user can specify a value or not specify a value. You can just supply the modifier by itself. And finally, for now, you can say that the user command does take a value, but the user can't just enter any value he wants. Rather, it has to be on this list of approved values. And you can mix and match all these parsing pieces just by putting them together, space separated, in the parsing string. That's what we're going to do. So here in summary, raw input, you take care of everything, and the input would just be the string that whatever the user had on the line. You can specify a number of arguments, and you can supply modifiers and restrict how they are to be used. With that in mind, let's add a modifier. So we do ULoad on our command, so we get the code into the workspace. And now we have the parsing string. So we're going to add to the parsing string that it can take a modifier called 2x. And 2x can optionally take a value which needs to be one of, say, XML format and JSON format and Unicode format. And now this also means that we can do conversion in both directions. Of course, we need to tell the user that. And then we need to modify our code a bit. So when we use the parser, the input argument is not going to be just a plain text vector anymore. Rather, it's now going to be a namespace with some predefined names inside, some variables. So specifically, the arguments, now there can be any number of arguments. Arguments will be in a variable called arguments. And we're only interested in the first and only one. And that's because either the user has to supply a hex code, which is just a single word, or it's a single character. So we're only interested in one. And the same thing down here. Right. But now, this was just a functionality in one direction, from hexadecimal to a character. We now need to say if the user at all supplied this this modifier or not. We need to take a different action. So there's a variable inside input which matches the name of the modifier. And if the modifier has been specified with a value, then this variable will have the value of that character vector that the user specified. If they just specify the modifier without a value, then it's going to be a Boolean 1, so it's not ambiguous. And if they didn't specify it at all, it will be a 0. So our old functionality is if you do not specify this 2-hex modifier, and so we can check whether that's 0. And if it isn't 0, then we need to take appropriate new action. So what do we need to do? Well, we get in the input arguments, and we just want the first one and only one, and we also just want the first character of that, because the first argument, even if it's just as a single character, it will be supplied as a one element character vector. So we find the Unicode value for that, that's the decimal value, and then we convert that to a 4-digit hex value. So we encode that as base 16. And we use that to index into our digits. That's going to be our hex code. And then some of these formats, they require a prefix. So the prefix for XML is an ampersand and a hash and an X. The prefix for JSON is a backslash and a lowercase u. And the prefix, according to Unicode, we should write a u with a plus. And for anything else that is for just 2-hex without any value, we put no prefix. And we select from that based on whether the value of 2-hex is XML or JSON or Unicode. So if the 2-hex is just a 0, then we never get down here. If it's a 1, then it will not be found in this vector, so we get 1 beyond the last one, and we get nothing. And then we put everything together. It's the prefix and the hex code. And we also need to add a semicolon if it is XML. Right, there we go. And then we should amend, of course, the help to say that you now can optionally specify 2-hex, and you can optionally give it a value which can be XML or JSON or UCS. And we should tell them about it if they want more help, what it exactly means. So 2-hex reverses, and maybe give them an example of how to use it. Character, and say this character in XML format. That's it, we're done. We can close this, and now we can look at the help for this command and we can try it. Oh, look at that, we got a value error. So notice that we did not like a normal APL function where we would get suspended when an error happens. Rather, the user command processor traps all errors and reports back that there was a problem with the user command code, and the user doesn't end up in any kind of bad state when that happens. However, we want to maintain our user command, we want to develop it, and so we need to be able to debug it. And so there's a user command called UDebug, which we can turn on. And now this allows user commands to become suspended when they hit an error. So if we try again the same thing, we now get suspended inside the user command. And we can see that we got a value error, and that's because digits was only defined inside this if statement. So we need to fix this. And we can see even quad.io was only set inside. So let's take these two out and move them into their correct location. And when I try to close the editor, we get asked if you want to save this back. So it saves back to file. And let's go up and try this again. And continue. And we got our properly formatted XML code for this character. Right. You might have noticed before that there was an argument to run and to help, which is the name of the command. That doesn't matter, of course, if you only have one command. But as you can also see by the one row here, we have a vector of one namespace indicating we have one user command being defined in this file. We can, of course, increase that and add as many commands as we want defined in the same file. And why would you want to do that? Is because if you have multiple related user commands, they could share some code, and that code could all be located inside the same namespace script. There could also be variations on each other, so that it's basically just one command, but with different names, and it does something slightly different for each one. It allows you to share the parsing specifications or other information, the help system, for example. So the template that we had generated from the unew already had a select structure in the run function and in the help function, but there was only one option there, that one command that we had defined. And then, of course, we can just add more cases as we add more commands in order to have this namespace define more user commands. So let's add another command. We can turn UDebug off again. And let's go in and edit this. So now we want not one, but two namespaces, and that means we have to have two names. They can stay in the same group. And then we add another line. So this one generates an APL or a JSON expression for an array. And for the parsing information, we're going to say that this one takes one argument, but it's long, because just like we had with peak, we just want an APL expression that may have spaces in it, so it looks like multiple arguments, but we just want it all together as a single expression. And we have a modifier, which is just JSON. So by default, it will be an APL expression, and if the user specifies -JSON, then they will get a JSON expression instead. So in the run function, here's the case for the character command, and we just add another one. And so first we're getting the array out. Because it's in an expression that the user supplies, we need to execute the first of the input arguments. And then we need to decide what to do with that. So if the user specified that they want JSON, then we will return a JSON export of the array. Else so you didn't want that, then we do it in APL instead. So there's this utility we can use. This is the represent an object on this array. And then we amend the help, of course. And again, some basic help, just showing the basic syntax. And then if the user wants more help, then we tell them that this gives you a and maybe an example too. Something complicated. And that's it. Let's try this. So when we ran unew, we automatically loaded in this new user command into the system. The system detected that there was a new file. However, now that we have amended the file, the system doesn't currently detect that. So if we try to get help on this command, it doesn't recognize that this command even exists. So we need to say UReset. That means go through all the files that are in all these locations for all the user commands and scan them again, look if there's anything new. And it says now that's 88 instead of 87 commands. So now we can look in our text group. It's not called text group, it's called, you can look here, my commands. And here we have the second one. We are working on improving this, and in version 17, which is out very soon, you don't need to do this anymore. It will automatically scan the files to see if there's anything new there. And we can get all the help, and we can try this example. And there we go, we get an expression for this array. So that's how you add another command to your existing script. So you saw me use some utilities. Here they are in summary. ULoad will find the code for a user command, load it into your workspace. UDebug, if you turn that on, it will allow you to be suspended inside a user command instead of trapping it and reporting it. It has another couple of effects that you didn't see, which is if you try to trace into a user command like you normally would trace into some APL, you will find yourself in the user command processor, which is also written in APL, and it's quite a bit of a way down until you actually get to your code. So instead, when you have UDebug on, then if you just try to run a command but you put a dash at the very end of the call, the system will pick this up and it will set a stop on the very first line of your code, whether it's the run function or the help function, and then you can trace on from there. So it's a convenience. And also, if you use ULoad to load in your command into the workspace, then and UDebug is on, the system will use your local version that's in the workspace instead of using the version that's on disk. And that is so that you can make experiments with your local version in the workspace without saving them to disk, and try those out as you're experimenting, without risking corrupting your original code. And then of course if you if everything works fine, you save it back, turn UDebug off, it will use the old code. It'll use the new code if you save it back, and if you turn UDebug off and you haven't saved it back, it will use the old version that was there. And then UReset, forcing the system to reevaluate all the files to detect if any user commands have been added or any of the syntax has been changed. Now I showed you how to use the unew user command in order to generate a template that you could then modify to your needs. Unfortunately, as it stands, the unew command does not work cross-platform. It uses a Windows GUI. However, in version 17, it will work cross-platform. It will skip the GUI and take you straight to an editor with the template, and you can take it from there on. And it will also take care of setting up the path and saving the file to a proper location. Meanwhile, you can go into your Dyalog install folder and find salt. In the salt directory, there's a subdirectory called study, and among other things, it has some sample files, and there are 2 of them, and they are templates that are well commented. You can just copy those, use them, modify them as you see fit to make your own user commands, and that of course works cross-platform. If you're interested in how the built-in user commands work, you can find those in the Spice folder under Salt, and you can copy that in. But don't modify the ones that are there in your install function, in your installed folder, or things that you might expect to work will stop working. So you can do this from inside APL. If you can use the load user command and give it a path like this, it can find its own salt folder by putting salt in square brackets. And you use the modifier no-link. That means you're loading this script into the workspace, but when you make changes in the workspace, do not save those changes back to files so that you don't corrupt the things that are in your install folder. So you can modify this as you see fit with the editor, and then you can use another user command, save, to save it back to any path. And then you have to make sure to set up manually also, because you're not using unew, the command here, that's the where the system looks for user commands, and you specify the path. The comma here, leading comma, indicates that you don't want to stop using all the built-in commands, rather you just want to amend and also use your new command. So this is how you do everything by hand. Again, the unew user command will work cross-platform in version 17 and do all this for you. And if you're happy with the results of it, then you can do settings command dir -permanent, so that the changes will have effect next time you start APL again. My vision here for 17 will be that you can even write unew and give it a couple of names of commands, and it will make a template for you that fits with as many commands as you supply the names of. So in summary, your user command namespace needs to have a help function, a run function, a list function, and you can use these utilities, ULoad, UDebug, and UReset. And so there's this really neat thing, as I mentioned, that you can take a user command file and give it to somebody else, and they can easily use that. So we'll go into a folder here, and we can see we have this text.dialog that we created before, and I can open my email, and I can just take this file, drop it into my email, and send it off to my friend, and they can very easily use my user command. So while it says ask questions now, I'm very sorry that the chat didn't work, but feel free to contact us by email or in Stack Exchange chat, and we look forward to seeing you again for the next webinar, which is on online data. As always, webinars on Thursdays, usually the third Thursday of the month, Thank you so much.